So section 9.1 is all about correlation. So correlation is just a relationship between two different variables. We usually call our x our independent variable and our y is our dependent variable. So what we can do is we can create a scatter plot. And a scatter plot is going to help us determine if we have a linear correlation between our two variables. So what I've done here is I've taken my 5 points and I've plotted them on the grid to the right. And as you are noticing, when I'm reading my graph from left to right, it's kind of trending upward, okay? So we have some different relationships between our correlations. We could have a negative linear correlation, and so in this case, the variables are going to do the opposite thing. As x increases, our y value is going to decrease, and conversely, if x increases, our I think I just said increases twice. As x decreases, our y increases. There we go. Positive linear correlation is when they both are increasing or decreasing, they're doing the same thing. If you see just like a random picture and it doesn't really follow any pattern, that's probably because there's no correlation. And in this case, we have a nonlinear correlation. And if you remember, this is a parabola. So this would have a quadratic correlation. Okay, so what I want you to do now is we have some data. So we have an economist is determining whether or not there's a linear relationship between a country's gross domestic product and carbon dioxide emissions. So it wants us to create a scatter plot. Okay, so I'm going to show you what I used for my x and my y axis, so you can create the same thing. So that's the scale that I used for my y, and that's the scale that I used for my x. Okay, so I found that by looking at my data here and noticing that the GDP ranges from a little bit under 1 to 4.9, so that's pretty close to 5. And then here my CO2 emissions, the largest value is about 12,000 and the smallest value is 264. Yeah, okay. So that's why I use that for my scale. Okay, so you're going to go ahead and plot the points. So pause the video so you can plot the points. Okay, so once you've done that, you should get something that looks kind of like this. So you're noticing maybe a positive linear correlation here. So let me switch to my pen. So the data is kind of trending upward to the right. Okay, so that means we have a positive linear correlation. Okay, so we are going to learn to do this in the calculator, all right? So what you're going to do is you are going to, I guess let me write the steps down first. Okay, so the first thing that you're going to do is you're going to enter your data into L1 and L2. Okay, so to get to your list, remember you have to hit stat and then edit. Okay. All right, after you've done that, you're going to hit second stat plot. And then you're going to hit graph. And you may need to change your window. And to do that, change window. Let me look at my calculator because I don't remember the buttons. You're gonna hit zoom, and then go down to zoom stat. Okay, so to change the window, you're gonna do zoom and then zoom stacked. Okay. So what it's going to display for you, oh, I took my data out of my list, didn't I? Okay, so I don't have a picture for you because I took my data out of my list, but essentially it's going to form the scatter plot for you, okay? And in this case, again, I have a positive linear correlation. It's not always going to be positive linear correlation. It just so happens that these two examples were. So we'll say positive linear. Okay. Okay, so we have a way to determine how closely related our variables are, and that is called our correlation coefficient. So what this does is it measures the strength and also the direction of the linear relationship between our two variables. Okay, so here's our formula, and you're probably like, whoa, that's a lot, right? So we're actually going to do this in our calculator so that we don't have to worry about that. Okay, so before I teach you those steps, what I want to bring your attention to is when R is close to -1, the stronger the negative correlation is. Okay, if it is exactly -1, then we have a perfect negative linear correlation. When R is close to 0, there's no linear correlation. And then the opposite of that, when R is close to 1, we have a perfect positive correlation, okay? So our range for our correlation coefficient is going to be between -1 and 1. Okay, so you'll notice here, we have a correlation coefficient of -0.91. And that is telling me that I have a pretty strong negative correlation because that's really close to -1. So what that is meaning as X is increasing, my Y value is decreasing. So these variables are doing the opposite. If I have a correlation coefficient of 0.88, that's pretty close to +1, which tells me I have a pretty strong positive correlation. We have a correlation coefficient of 0.42. So in this case, you can tell by the data that there's still a trend as you're going to the right that it's increasing. So we do still have a positive correlation. It's just not as strong because look at how far these data points are apart from each other. All right, and then here, this value of 0.07 is very close to 0, so there is no correlation here. Okay, so now what we're going to do is we're going to calculate the correlation coefficient. And before you perform these calculator steps, you're going to have to turn on the diagnostic. So to do that, what you're going to do is you're going to hit the second button. Diagnostics. Okay, so you're going to hit second and then catalog. It's where the 0 is. And you're going to scroll all the way down to the D's, and then you're going to select the thing that says diagnostics on, and you're going to hit enter, and then it's just going to tell you that it turned it on. Okay, you have to do this to make sure that you can see the data. And then what you're going to do is, after you've done that, you're going to again enter the data into the list, and list 1 and list 2 preferably. Then you're going to click stat. You're going to go over to calc, and then you're going to select the option that says lin reg a plus b x. All right, there's another thing that says frequency list when you select this. So you're going to tell the calculator that L1 contains your x values and L2 contains your y values. And then you're going to leave blank the thing that says frequency list. And then you're going to hit calculate, and it'll tell you what the R value is. And in this case, Actually, I'm not going to tell you yet. I want you to pause and type all this in so that you can actually follow the steps. But once you've done this, you will get an R value . 0.8825. So what that is telling me is there's a pretty strong positive correlation between the GDP, the gross domestic product, and CO2 emissions. Okay, so you're probably getting a little bit sick of hypothesis testing. All right, so we're still going to be using this, and it's going to help us determine whether or not the sample correlation coefficient has enough evidence to conclude something about our population correlation coefficient, right? And our hypothesis test, as you know, can be one-tailed or two-tailed. Okay. All right, so here we have our three different options for testing. If we have a left-tailed test, our null hypothesis means we're going to have no significant negative correlation, and the alternative means there's significant negative. For our right-tailed test, it's the opposite of that, no significant positive or significant positive. And then when we have our two-tailed test, we're just going to say no significant correlation or significant correlation, okay? And this makes sense because when we have a correlation coefficient of 0, that means we don't have significant correlation, okay? All right, so this time our test statistic is going to be R, and we have a new formula. So one of the things that I really want to draw your attention to as well is we're still going to be using our t-distribution, but in this case, our degrees of freedom is going to be 2. Okay. And for the scope of this course, we're only going to be focused on two-tailed hypothesis tests for this. Okay, so we're not going to worry about left and right-tailed when we're working with this. Right. Okay, so here we go. So per usual, we're going to state our null and our alternative. We're going to identify our alpha significance level, degrees of freedom. Remember, it's different this time. We're subtracting 2. Either use your calculator to find your critical value, or you can also, you can also use the table in the back of the book. You're not allowed to judge me for being tired. All right, then you're going to plug into your formula, and then from there you can make the decision whether or not to reject based on if the standardized test statistic is in the rejection region. Okay, and then of course we always interpret. Okay, so we have our correlation coefficient of 0.882. And our alpha level is 0.05, okay? So the first thing that I'm gonna do is, as I said before, we are only gonna be dealing with the two-tailed tests. So we have H naught, which is P equals 0. HA, P is not equal to 0. And what this means is we have no correlation and significant. Okay, so the first thing that I'm going to do is I'm going to find my t critical value. And so to do that, I'm going to use my calculator. And so I'm going to use the inverse t feature. And remember, since this is a two-tailed test, what do you need to do with your alpha? You need to divide that by 2. So 0.05 divided by 2. And my degrees of freedom in this case is going to be 8, okay? Because I have got 10 total values here, and we are going to subtract 2 this time. All right, so if I use that feature, that's going to give me a t critical value of plus or minus 2.306. So that tells me I have my 2 rejection regions. greater than 2.306 and less than negative 2.306. Okay, so now let's actually find that standardized test statistic. So in this case, I'm getting, okay, so here's my formula, T equals R. Okay, and this is all under this square root here. Okay, so we're gonna say 0.882 over 1 minus 0.882 squared, 10 minus 2. This was a 1 minus, okay, square root. All right, and then I'm going to plug all that in, and I'm going to get a t-value of 5.29. Okay, so what does that tell me? Bam, it's somewhere over here. Okay, so that's definitely in my rejection region. So we're going to reject the null, which means there is significant correlation at the 5% level. Okay. All right, there's one more example on this, and I actually want you to try it. Okay, it's really similar to the last one. And I want you to check my notes online to make sure that you've got it correct. All right.